Okay, so we are going to do just a really quick review with inequalities. Okay, so we did this back when we were solving equations. So if we have 4 minus 3x is greater than 10, you need to remember how to solve this and how to graph this. So I'm going to subtract 4 on both sides. Do not forget to drop down the negative with the 3x is greater than 6. This is that one rule that you have to remember, and that is if you multiply or divide both sides by a negative, which we are doing right now, then in the next step you have to switch the sign. So x is less than 2. So when we were doing this, we were working with these on a number line. So we would mark 0 and we would mark our negative 2. And then we had to determine, is our circle open or closed? So because it does not have the equal to part, it was open. And remember, I read it from the variable. X has to be less than negative 2. So I'm looking for all the solutions that are less than negative 2. So not only do you have to recognize whether this is open or closed, then you had to remember the shading, because it wasn't just one number that it was equal to, it's a whole bunch. So that shading represents all the numbers that would actually be a solution. So we are going to step it up a notch, and we are going to be graphing these on a number line. So let's do example 1. Y is greater than negative 3x plus 4. When you're doing, when you're graphing these, I would always put in slope-intercept form. Just much quicker, and we have been working on that for a long time. So it is in slope-intercept form, and I'm going to cheat a little bit so I don't have to draw a nice graph or anything. I want to put this graph here. So my y-intercept is 4. Can't talk with that in my mouth. So the y-intercept is 4. So I'm going to go 1, 2, 3, and 4. Actually, I'm going to tape this a little bit so I don't have to hold on to it. Okay. And then our slope is negative 3, or negative 3 over 1. So that means from my y-intercept, I'm going to go down 3 to the right 1. I'm going to go down 3 to the right 1, and I like to do it a couple times. Now, before, when we've been graphing lines, we just zip, and we draw the line. But remember, if we're dealing with inequalities, this is where we had that closed or open circle, and we had shading. Well, now since we're dealing with lines, if you have a greater than or less than, we have a dotted line or a dashed line. Okay, so that is equivalent to the not equal to piece. We have, if we have less than or equal to, greater than or equal to, which is what we've been doing so far, that's where we have a solid line. So I'm looking at this. It's going to be dotted because I do not have the equal to piece. So I'm going to lay my straight edge up here, and I'm going to dash it or dot it, however you want to think of it. Okay. Now, when we had this one up here, we also had shading, and there is going to be shading here. So what I like to think of is start back to your y-intercept. So here's my y-intercept. I want all the values that are greater than where I'm at right now. And this goes in relation to the line. So I want all the values that is greater than where I'm standing on the y-axis. So that means I'm looking at this side of the line. So this is where I would shade. So the greater than means that you'd be shading going up. Okay. A way you can check it is if your line is not going through the origin, because this one is not. I have this point here of 0, 0. If I plug 0 in and 0 in here, it better be a true statement. Is 0, I'm going to write the check, is 0 greater than negative 3 times 0 plus 4? Is 0 greater than 0 plus 4? Is 0 greater than 4? So is 0 greater than 4? The answer is no. Therefore, this should not be shaded. And 0, 0 is right here, and it is not shaded. Let's pick an ordered pair up here that is in the shaded. So I'm going to pick something that is clearly in the shaded. Let's do 1, 2, 3, 4, 5, 6. So this would be the ordered pair of 6, 0. So this should be a true statement because this point is in the shaded part. So I'm looking at 6, 0. So if I plug that into my original, I have 0 is greater than negative 3 times 6 plus 4. 0 is greater than negative 18 plus 4. 0 is greater than negative 14. Is 0 greater than negative 14? Yes, it is. Therefore, this should be shaded. Okay, let's do a couple more of those. So let's do example 2. We have y is greater than or equal to a negative 4. So again, actually, I'm just going to draw this one up. This is an easy one. So if y is greater than or equal to a negative 4, that means that all of my y's would have to equal a negative 4. We're not worried so much about this sign yet. So if you need to think about it as an equal sign, then do that. But this is what your greater than or equal to is going to come out in your dotted or your solid line. All my y's have to be a negative 4, so I can make my x's anything I want. So 3 in negative 4, 2 in negative 4, and 1 in negative 4. So my line is going to be going this direction. Before I zip my line, I'm going to look to see, should this be solid or dotted? And this should be solid because it has that equal to piece. Okay, and then I have to do my shading. I want all the values of y greater than where I'm at. So right now I am right here. I want everything greater than . So any ordered pair in this shaded area will work. So if I put a 0 in here, 0, 0, is 0 greater than or equal to a negative 4? Yes, it is. So that's why it should be in the shaded section. Let's do sample 3. X minus y is greater than 2. I'm going to solve for y, put this in slope-intercept form. Subtract x. Don't forget to bring down the negative y. Remember, these are not like terms, so we cannot combine them. And I do like to put that negative first, or that negative x first, rather. I'm going to divide every term by a negative 1. So because I just divided everything by negative 1, I have to switch the sign from greater than to less than. This gives me x, and this gives me a negative 2. And this isn't a bad one to graph. So this negative 2 is my y-intercept. Slope is a positive 1, or 1 over 1, so that means up 1 to the right 1. Up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. Before I zip my line, I'm going to check to see if it should be dotted or solid, and does not have the equal to piece, so it is going to be dotted. Or dashed, everyone think of it. And I want all the values of y less than where I'm at. So I'm going to find my y-intercept. I want all the y's that are less than where I'm at, which means it's going to be this side, okay? This shaded area is actually called, or the whole thing is called, a half plane. Because what you're doing is you're taking this coordinate plane and you are dividing it in half. So this is the shaded half plane. This is the non-shaded half plane. I have one more example that I want to do just to make sure that we're all on the same page with graphing. So we have 3x minus 2y is less than 10. This one is definitely not in slope-intercept form, so we're going to do that. Subtracting 3x on both sides. So negative 2y is less than. These are not like terms. So I am not going to combine them. I'm going to put the x term first. Divide everything through by a negative 2. I just divided everything by a negative number, so I have to switch the sign from less than to greater than. This gives me 3 halves x, and this is going to give me a negative 5. So my y-intercept is at 0, negative 5. Slope of 3 halves, it's a positive slope, so that means up 3, to the right 2. I'll do that again. Up 3, and to the right 2. I'm going to look and see if my line's dotted or solid. It is dotted because it does not have the equal to piece. And here's where I'm at y. I want all the y's that are greater than where I'm at on the y-intercept. That means I'm going to be looking at those because those are all greater than. So this is the half plane for all of my solutions could possibly be. So you need to remember that the shaded area represents all possible solutions to the inequality. The shaded area represents all possible solutions, which in this case are ordered pairs, to the inequality.